Welcome to Kishore's Neet Parasala. In this video lecture, let us see about the concept of projectile motion. Okay, let this be the y-axis and this be the x-axis. We are throwing a ball with speed, initial speed u, with an angle theta with horizontal direction. So here when we resolve the component, the speed along the angle comes out to be cos theta, so u cos theta, and the component which comes away from the angle is sin theta, so we are resolving it as u sin theta. In the previous video lectures, I would have put a separate video for resolving of component. If you have doubt in this, you can see that video and get clear concept. Okay, so the speed along the x-axis comes out to be u cos theta, and what is the distance covered by it at time t. So they are asking what is the horizontal distance covered by it in time t, which is nothing but distance covered is nothing but velocity into time, which is along the horizontal direction u cos theta into t is the distance traveled by it in time t. So d by t is equal to u cos theta, so v is equal to u cos theta. This is a formula you must remember. In the next video we will see about its application, so this formula you must remember. Next formula you must remember is time of flight. They are asking, suppose we are throwing a projectile with theta in horizontal direction and they are asking the time of flight, then it is nothing but 2u sin theta by g. Next, range, they are asking, range is nothing but the horizontal distance covered by it in the whole journey is the range. Suppose if it is moving up to this distance, then this distance we call it as a range. Range is nothing but range is, we can give range by u square sin 2 theta by g. We know that sin theta is 1, which is the maximum value of sin at theta is equal to 90 degree. So here in this case, if theta is 45 degree, then sin 2 theta value comes out to be sin 90 and the range is maximum. So at theta is equal to 95, range is maximum. Here when theta is equal to 90, time of flight is maximum. Next, maximum height reached is u square sin square theta by g. Here when theta is 90 degree, the maximum height is reached. Now the next formula you must remember in this concept is, suppose the final velocity of the projectile is perpendicular to the initial velocity, then v is equal to u cot theta. This is the special case you must remember in case of projectile. That is, if final velocity is perpendicular to initial velocity, then v vector is equal to u cot theta. And you must also remember the formula of the projectile, that is x tan theta minus g into x square by 2u square cos square theta. This is nothing but it is similar to the formula ax minus bx square, which is the equation of parabola. So we can say that the projectile motion follows the path of parabola. Next point you must remember is, suppose if we are throwing the projectile 1 with theta 1 and projectile 2 with theta 2 with respect to horizontal. Suppose if theta 1 plus theta 2 is 90 degree, then the range reached by the first projectile is equal to range reached by the second projectile. Suppose theta 1 is theta minus 45, theta plus 45, and suppose theta 1 is 45 plus theta, and theta 2 is 45 minus theta. Then we can say that theta 1 plus theta 2 is 90 degree. So range reached by first projectile is equal to range reached by the second projectile. Next, one important formula you must remember here is tan theta. That is that here theta is the theta with the horizontal, the same thing. Tan theta is 4 into h by r. H is the maximum height reached by the projectile and r is the range. If theta is equal to 45, then h is equal to r maximum by 4. That is, if theta is 45 degree, then range is maximum. These are all the formulas you must remember in case of projectile motion. Now let us see certain special cases. Suppose if I am throwing with an angle theta degree and h is the height reached at time t1 and the same height is reached at time t2, then time of flight is nothing but 2u sin theta by g, that is equal to t1 plus t2, and height reached h is equal to 1 by 2 into gt square, we know that is g into t1 into t2, and average velocity in this time, let this be a, this be b, average velocity in the interval ab is u cos theta. And let us see the next thing. Next special case let us see in this slide. Suppose we are throwing the first projectile with angle theta. Its maximum height reached is h1, and let us throw another projectile, that is the second projectile, with an angle theta with which reaches the maximum height of h2. Then we can say that ratio of height obtained is h1 by h2, that is equal to tan square theta. Okay, see that here both the cases theta is same. Next, time of range, ratio of time of flight is tan theta, and r range reached is 4 into root of h1 and h2, and this is the most important formula. Then you can also say that the range reached is 1 by 2 into g into t1 into t2. Okay, now let us see another one special case. Suppose here this is theta 1 and this, let this be theta 2, in which first projectile it reaches this point, second projectile it reaches this point, and all the cases, suppose if the height obtained is same, in all the cases the height obtained is same and it is h, then we can say that u1 sin theta 1 is equal to u2 sin theta 2 equal to un sin theta n, and u1 is less than, u2 is less than u3, and remember that in all the cases t1 is equal to t2, that is equal to tn. Next video we will see the applications of these formulas. I hope you like this lecture. Please subscribe my YouTube channel Kishore's Neet Padasala. Thank you.